the Panzerkampfwagen VI Tiger. If you watch Hollywood movies or play video games, this machine is the ultimate apex predator. It is presented as an invincible monster that required 5 Shermans to destroy. It is the pop culture icon of the Second World War. But pop culture does not care about logistics, and it certainly does not care about transmission gear ratios. In the cold, muddy reality of the Eastern Front in 1943, the Tiger was often a logistical nightmare that defeated itself. Here is the paradox we are analyzing today. German engineers built the most feared gun of the war and mounted it on a chassis that technically could not support it. Imagine taking a Formula One engine and bolting it onto a tractor made of lead. We are not looking at armor thickness or kill counts today. We are looking at the boring parts, the final drive gears, the road wheels, and the supply chain. These are the specific pieces of metal that explain why Germany lost entire heavy tank battalions without the Allies firing a single shot. The unit cost of a Tiger was roughly 300,000 Reichsmarks. Adjusted for inflation and purchasing power parity, that is roughly $3 million in 2025 money. For comparison, a Panzer IV cost half that amount. Yet despite this massive price tag, the Tiger had a transmission lifespan of just 150 kilometers. Why did a nation famous for precision engineering build a tank that struggled to drive to the battlefield? To understand the failure, we first need to look at the industrial context and the weight spiral. By 1942, the German high command was in a panic. Their standard tanks were bouncing shells off Soviet T-34s. They needed a breakthrough vehicle. The initial specification from the procurement office called for a 45-ton vehicle. Henschel, the manufacturer, designed the chassis for exactly that weight. But then came the feature creep. Hitler and the upper command demanded thicker armor. They demanded the massive 88mm KWK-36 gun. They demanded deep wading capability so it could drive underwater. The result? The final combat weight ballooned to 57 tons. But here is the critical engineering failure. While they drastically increased the weight, they did not redesign the drivetrain to handle it. They were running an industrial war on a fix-it-later mentality. The Tiger was essentially a 45-ton design screaming under the load of a 57-ton reality. Let's look at the heart of the machine, the engine. To move 57 tons, the Tiger used the Maybach HL230 P45. On paper, it produced 700 horsepower. That sounds impressive, but physics disagrees. That is a power-to-weight ratio of only 12.3 horsepower per ton. For context, a modern American M1 Abrams has double that ratio. Even a standard modern garbage truck is more agile. To get the Tiger moving from a standstill, the driver had to rev the engine to its absolute limit. This put immediate, catastrophic torque on the transmission. A Sherman driver could be rough with his tank. A Tiger driver had to drive like he was handling fine china. If he accelerated too aggressively, the sheer mass of the vehicle would shred the teeth off the gears. This leads us to the transmission itself, the Olvar gearbox. This was a semi-automatic, hydraulically pre-selected system with 8 forward gears. It was a marvel of complexity. It allowed a 57-ton tank to be driven with a steering wheel and 2 fingers, rather than the muscle-straining levers found in Soviet tanks. But complexity in war is a liability. The gearbox required delicate maintenance and perfectly machined parts. By 1943, the Allied blockade had cut off Germany's supply of rare earth metals like manganese and molybdenum. These metals are crucial for hardening steel. Without them, gears become brittle. So German factories were forced to install softer gears into a tank that was already overweight. The result was inevitable. The final drives, the gears that transfer power to the tracks, would simply shatter under stress. Now, let's talk about the wheels. This is perhaps the most over-engineered and problematic feature of the Tiger. The Schachtellaufwerk, or interleaved road wheels. If you look at a Tiger, you see layers of wheels overlapping each other. Why did they do this? The engineers needed to distribute that massive 57-ton weight so the tank wouldn't sink into the ground. By using many overlapping wheels, they spread the load perfectly. It gave the Tiger a smooth ride, providing a stable firing platform for the gun. From an engineering standpoint, it was brilliant. From a maintenance standpoint, it was a disaster. Imagine it is winter on the Eastern Front. You are driving through deep mud and slush. That mud gets packed between the interleaved wheels. When you stop the tank for the night, the temperature drops to -20 degrees. The mud freezes into solid blocks of concrete hard ice. The next morning, the tank is immovable. You cannot chip the ice out because the wheels are overlapping. You have to use blow torches to melt the ice, risking a fire, just to get the wheels turning. Furthermore, if an inner road wheel broke, and they often did due to mines or wear, you couldn't just replace it. You had to remove up to 9 outer wheels just to access the one broken inner wheel. A repair that took 30 minutes on a Sherman or T-34 could take an entire day on a Tiger. In war, time is the one resource you cannot buy. The logistical problems didn't stop at the wheels. Let's talk about getting the Tiger to the front. You couldn't just drive it there because the transmission would break after 150 kilometers. You had to use trains. But the Tiger was too wide for standard European railway tunnels. It physically wouldn't fit, so every time a Tiger unit needed to move by rail, the crews had to perform a massive mechanical operation. They had to remove the wide combat tracks. Then, they had to remove the outer layer of road wheels. Then, they had to install special, narrower transport tracks. Once they arrived at the destination, they had to do the whole process in reverse before they could fight. This took hours of back-breaking labor. While Allied tanks rolled off the train and drove into battle, German crews were playing mechanic for 4 hours, vulnerable to air attacks. Now consider the fuel economy. The Tiger I carried 540 liters of fuel. Off-road, it consumed roughly 5 liters for every single kilometer. That is not a typo. 5 liters per kilometer. A single Tiger battalion required a dedicated fuel train just to conduct a minor offensive. When Germany began to run out of oil in 1944, the Tiger became a strategic liability. There are dozens of reports of Tigers being abandoned simply because they ran dry. A 57-ton tank without fuel is just a roadblock. But the ultimate humiliation was the recovery process. Let's say a Tiger's transmission fails in the middle of a retreat. You need to tow it. But you cannot use a standard recovery vehicle. It is too heavy. The manual specified that you needed 3 18-ton half-tracks chained together to tow one Tiger. Think about the economics of that. One broken tank effectively removes 3 other heavy vehicles from the operation. If you didn't have 3 half-tracks, you had to use another Tiger to tow it. But towing a 57-ton load put so much strain on the towing Tiger's engine that it would often overheat and break down too. It was a chain reaction of mechanical failure. This is why so many photos from 1944 and 1945 show Tigers by the side of the road, intact, with no battle damage. The crews simply blew them up with demolition charges and walked away. The machine hadn't been defeated by the enemy, it had been defeated by its own blueprint. Let's look at the manufacturing cost in terms of time. It took approximately 300,000 man-hours to build a Tiger. In the same time, the US could build 3 or 4 Shermans. The Soviets could build even more T-34s. The German philosophy was quality over quantity. They believed one superior tank was worth 5 inferior ones. But this ignored the reality of attrition. If your superior tank is in the shop for transmission repairs 40% of the time, it provides 0 value on the battlefield. Availability rates for Tiger battalions rarely exceeded 60%. That means for every 10 tanks on paper, only 6 were actually ready to fight. The other 4 were being worked on by exhausted mechanics, waiting for spare parts that were stuck on a bombed-out railway line. Compare this to the American approach. The Sherman tank was not a great duelist. Its armor was thinner, its gun was weaker. But it worked. It had a simple engine, a simple transmission, and parts were interchangeable. If a Sherman broke, you could swap the part in an hour. If a Sherman engine died, you could lift a new one in with a basic crane. The Tiger required a specialized portal crane to lift the turret off just to change the transmission. So, did the money save them? No. The Tiger represents the fundamental flaw of the Nazi war economy, the obsession with wonder weapons. They sought engineering solutions to strategic problems. They believed they could design their way out of being outnumbered. Instead of building a reliable, standardized tank like the Panther should have been, they poured resources into a low-production, high-maintenance boutique monster. They built a machine for a war where fuel was plentiful, air superiority was guaranteed, and maintenance depots were close by. That was the war they wanted. But in the war they actually had, the Tiger was a dinosaur. The legacy of the Tiger is a lesson in the difference between tactical and strategic. Tactically, in a one-on-one duel, the Tiger was superior. It could kill anything from 2 kilometers away. But wars are not won by duels.